Hello everyone. So let's try to solve this problem on Leetcode. It's can place flowers. You can read about this problem more in details. I will put the link in the description, so you can go from there and you can read. Basically, what this problem is trying to tell us is that, let me show you with an example, that there will be some like 0 and 1. Basically, let's try to read one more time. So you have a long flowered bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plot, meaning like next to one another. Given an array integer flower bed containing zeros and ones, where zero means empty and one means not empty, obviously, and an integer n. Return true if n new flowers can be planted in the flower bed without violating the no adjacent flowers rule and fails otherwise. Basically, what we need to do is we will be given on this array and there will be n. N is like the flowers that we need to plant, meaning we need to put ones inside this array. So there will be some ones already put in inside this array and there will be zero. So we need to put this much n into position of zeros. But we need to make sure that when we put this 1 on the position of 0, we need to make sure that there shouldn't be flowers cannot be planted in adjacent plot, meaning we can't put one here, because if we put one here then there is already one here, so it break these rules of adjacent, meaning if I put one here then left and right side of the particular one there should be 0, like there shouldn't be another one. This is what it means. So in the diagram, if I say tell you that this is the, let's just say example we take, and this is the array and we need to put ones inside. So if I put one here then I cannot put one here, I need to put here. If I put here then I cannot put here on here, so I have only remaining index is this. This is the valid what do you call it, a placement of these flowers. So we need to put n number of, we will be given n number, so we need to tell, for example let's just say this is 3. For example in this we have given 3 n, so we can put them, right? So the answer should be true, like yes we can put them. But if there's instead of 3 there was 5, sorry 4, then we would not be able to place them. Like for example, where will you put the fourth one? We can't put here, because if as soon as I put here, this violates the rules of adjacent, right? So this was the question that was asking us. So the answer is very like simple, but in this video we will try to understand why that solution works. So the solution is very simple. We try to put like start from like let's try to understand this with like intuition. If I don't tell you this how many and you can put and there, so how will you like maximize the number of ones you can put inside this array? Obviously you will try to put first, as soon as you see the position we will put one here. Then what you will do, you know that you can't put next to it, so you will jump two and you will put here, and then you can't put here, then you will put here, and you can be damn sure that this placement is the maximum number of ones we can put inside this array, right? Because there's no way we can put more than one. Because if we try this way, like for example if I put one here, then I know I cannot place one here or one here, so I can place here, but then I can't place one anywhere else in this array. So we put this time in this arrangement we will put two ones inside the array, but before that we were able to put three in this placement, like one here, one here, and one here, in this order, right? So we know that as soon as we see the position we put one, and then we will check on the next position, can we put here? So here we cannot put because of this one, so we move to the next one. Same thing we check, if there is 0, okay, put it here, because we can put this inside this at 0, so we can put here. Then we move to the next position and continue doing until the array ends. So this is the like a basic algorithm, but the only twist here is that there will be some ones already in the array. Like there are some positions, for example let's just say this one will be given into our array, so we need to incorporate that also. Like we don't have this freedom, like there will not always will be 0, because if that's the case then we can definitely like obviously we will choose this one, this combination of first putting one here, then next, then next, next, next. But if this is the example that we are given, for example, so we know that we can't put 1 here, because in the exam, like in the input, we have already have 1 here. So we will check, okay, can we put here, can I put here, although this is 0 and I can put here, but I cannot, because that will break the rule of adjacent. So we need to see that, like, think about that also. So for that reason only, and the intuition is very simple, is that whenever we see the position, we make sure, can we put 1 here, and if we can, we will put there. That's it. This is the answer of this problem, and this will work perfectly fine, because, as I said, there will, like for example, if we put 1 here, then I know from here to here, no matter how many zeros are there, ones are there, no matter in which position we will put 1 and 0, in at whatever position we put ones, and however arrangement we decide, this will not be affect this one. So because of that, we will make sure that whenever we see the one, whenever we see the position empty, we will try to put 1 here. If we can, we will put there, and we will be sure that this placement is right, and we will move to the next one. So that's the solution, that whenever we see the position, we will put 1. So if this was the example, we will see, can I put 1 here? I cannot, because this is already in the example, there is 1. So I cannot put. So I will come to this position this time, and I will see, can I put 1 here? I can't, because there's already 1. So I will move to this position. Can I put 1 here? I can't, because there's already 1 this side and this side. So this side we don't have to check, because this side already 1. So we cannot put here. Can I put here? Yes, I can, because as soon as I put there, I will check, okay, left side or right side, check. Is there 1? No, there's no 1. So we can put here. Great. So we will put 1 here. Then we will move to this one. But because we put here, so if I try to put the 1 here, I cannot, because there is already 1 I have put into the left side of this position. So it's not possible. And after the, like a certain time, the loop ends, and we have traversed the entire array, and we will say, okay, I can only put one ones inside the array. So we will check if this number is greater than the n that we are given. If yes, then I know that I can put more than n elements, so I can definitely put n elements. So I will return true, otherwise I will return false. That's the answer. So let's try to see the answer of this problem. I have already wrote the code for you. So I have run a loop. As I said, we will start from the beginning. If the current element is 1, then we know that it's already flower was inside the, like this. For example, there is already 1 inside that. So we can't put here. So we will not do anything. We will just move on. And we need to take care of the 2 cases. Like first one is like, what if let's just say this kind of input, where 1 is already at index 1. So we need to take care of that. This is like like 0 at the last index, and we are trying to put there, and we can put here, like this is the valid index, and we can put here. So we know that we don't have to, like, we don't have right side of anything of the at the end of the array, right? So we don't, so we are checking that, like if we are the last index, then we only have to check the left side of it. If left side is equal to 0, then we can put here, right? Because as you can see in this example, let's just supposing we are here, then we know we only have to check this side. We don't have to go right side, because there is no right side. So we can put it. So we will put there. And n minus 1 we are doing, for example, I'm not making another variable for count, but I'm just reducing the n that we are given. And this will also work the same way, because if the n is less than 0, then we know that we have put all the n floors that were given to us, which means we will return true. So this is how it will work. And this condition will take care of this example, where we can put at the first index. So in this case, I can't check to the left of it, because there is no left of it, because array index start from 0, right? So in that case, I will put that, and I will reduce n minus 1, meaning I put it there. So I have put 1 flower there. Minus 1 mean this is what minus 1 represent. So I have put the flower, meaning at current index it was 0, so I put 1 there. And then if these two conditions are not there, meaning the current index is kind of in the middle of it. So in the middle, we already know that if we are somewhere here, then we will, if I am here, then what I will do, I will check left and right. If there is 0 left and right, then I can put it. So this is exactly what I'm doing. I'm checking if the left element of current index and right element of current index is 0. If they are, then I will reduce -1, which means I have put one flower at this position, and putting flower mean putting one at this current position. I'm doing that, and that's it. And after the loop ends, I'm returning this. If n is less than is equal to 0, meaning I have put all the flowers inside the array, so I return true. Else, if this condition is not false, like this condition is n is greater than 0, meaning there are um, some flowers left that I had not put inside the array, and I was not able to do that. So I will return false, and that's it. I have accept. This is the accepted solution. So I will link down that also, and you can go and copy paste it. And that's it. I'm sure you can, like optimize little bit of it, but for the sake of understanding, I have written in a little bit of long format. But I'm sure you can optimize a little bit more. But the time complexity of it, order of n, and space complexity is like order of 1, because we are not taking any extra space. We are just manipulating the current space that is given to us. So yeah, that's it in this video, and I will see you in the next video, or some exciting things coming for you guys for the new year. Yeah, thank you so much, and